Now for this section, we're going to talk about how do we quickly sketch exponential functions here. Now the thing to understand about exponential functions is they're pretty simple looking functions here. So exponential functions, like their name, they are an exponent where your base is going to be a number and your exponent is actually where your variable is going to be. One of the first things that you do want to pay attention with an exponential function is you do want to pay attention to the value of b. Is b greater than 1 or is it between 0 and 1? Because if b is greater than 1, then you are talking about an increasing function. And an increasing function has this shape. On the left-hand side, it's going to be pretty low, close to the x-axis over here. And as you go to the right of the graph, it's going to increase exponentially, right? It's going to get bigger, bigger, bigger very, very quickly. That's only when your base is greater than a 1. All right, so anything greater than a 1 is going to be your increasing function. Otherwise, you want to pay attention when your base is between 0 and 1. So that might look something like this example here, where our base is a 1/2. Now, if your base is between 0 and 1, then you are looking at a decreasing function. A decreasing function from left to right is going to decrease exponentially. On the left-hand side, it's going to be really high up here, and then the more that you go right, it's going to decrease, 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 and continue to decrease there. So that's one of the first things you want to pay attention to, again, because increasing is going to have this shape, decreasing is going to have this shape. Now, there are a few other transformations and things to be aware of, though for this video, we are talking about quick sketches of these here. But some of the two most important transformations you do want to pay attention to up here in the exponent. If you have a plus or minus number next to your x in the exponent, this is a horizontal shift. So this is going to move your graph left or right. If it says x plus 2, you're actually going to move left 2. If this would have said x minus 3, then we'd go right 3. So you're going to look at the number, how much you're going to move, but kind of think the opposite sign. Plus 2 actually means minus 2. Whereas a minus 2 would actually be to the right 2, so like a plus 2 type of thing. Otherwise, if you have a plus or minus number hanging out at the back of your equation, that is a vertical shift. So you're going to take your graph and you're going to go up or down exactly what that number says. If it says minus 1, you're going to go down 1. If this is plus 2, you're going to go up 2. Otherwise, we're going to do quick sketches of these. And since these are just exponents here, pretty simple functions, we are going to just use an XY table and plug into your XY table, get a few points, and then graph. As I mentioned earlier, one of the first things you want to pay attention to, are you talking about an increasing or a decreasing function? For this first example, our base is a 2. And if our base is a 2, it means we are looking at an increasing function. Now, for me, what that tells me is it makes a difference on the points that I'm going to pick to plug in. Because on the left-hand side, if you notice with with the increasing function, the left-hand side almost looks like a horizontal line. So if I keep plugging in negative numbers over here, it's almost going to look like a straight line. So I don't want to do too much of that. When I know I'm working with an increasing function, I tend to pick one negative number. So let's just say that's a -1. I pick 0. And then I'm going to pick at least 2 numbers on the right-hand side over here. So let's see, I'm going to pick a 1 and then, let's see, maybe a 3. All right, so I want more numbers on the right than I do on the left because I know on the right-hand side it's going to do this steep curve. So I want to see more what's going on there. So plug in those values directly into your function here. So I'm going to find f of -1, which just means I'm going to plug in -1 into x. This is going to look like 2 to the -1. And if you plug that into your calculator, or if you simplify using the negative exponent rule, 2 to the -1 is actually equal to 1/2. Now, if we continue to do the same thing, plug in f of 0, that's going to give us 2 to the 0, which is equal to a 1. Plug in f of 1, that's going to give us 2 to the first, which is a 2. And then f of 3 is 2 cubed, which is an 8. So this gives me 4 points that I know that is on my graph. So I'm going to take those points and I'm going to plot them here on my graph, starting with a -1, and then a positive 1/2 is about there, 0, 1, 1, 2, and then a 3 and an 8 right around there. So if I connect these dots, it looks like this. Now on the left-hand side, I should know that this is going to continue to curve here, just knowing what exponential graph looks like. If you feel better and you want to plug in maybe like a -3 over here just to make sure, and go ahead and find f of -3, that's actually going to give you a 1/8 when you plug that in. So we can see here at a -3, it's going to be so close to 0 right over there. So it is going to continue to hug that x-axis. So there's our quick sketch for that function. Moving on to our next example. Our next example is also an increasing function because our base is a 2. Remember, if it's greater than 1, it's an increasing function following this shape right over here. So this function over here has our transformation. So as I kind of spoke about earlier, this x plus 2 means we're going to take this graph and shift it to the left 2 times. We are also going to shift it down 1 time because of this -1. So since the base is actually the same on these, this function for example B is actually this exact graph, just moved over 2 to the left and 1 down. So actually, if we took this graph and took every single point, it went 2 to the left, 1 down. And if we did 2 to the left, 1 down, 2 to the left, 1 down, 2 to the left, 1 down, we would get this graph. Now, we can still plug in and use an XY table as well. I know that this is going to be an increasing function. So let's see, if I took this graph and just moved it 2 to the left and 1 down, I'm actually going to just use maybe similar x values, but since we're shifted 2 to the left, maybe just subtract 2 from every single one of these x values. Let's go with a -3, a -2, a -1, and then maybe a 1 here. And then we can add in, if we need to here, we can add in an extra value here at a -5 if we feel like we need it. Plug it into this function and simplify. So if you are able to use a scientific calculator, you can go ahead and type that in easily to get these. Otherwise, I do like to simplify things by hand. I'm a little old school. So let's see, plug in a -3. So 2 to the -3 plus 2 minus a 1. Well, -3 plus 2 is a -1. And keep in mind, 2 to the -1 is a 1/2. And 1/2 minus 1 is a -1/2. So I'm going to get a -1/2 right over there. 2 to the -2 plus 2 minus 1, right? I'm going to keep just plugging in here. Well, -2 plus 2 is 0, and anything to the 0 power is a 1. So this actually is 1 minus 1, which is 0. 2 to the -1 plus 2 minus a 1. Well, -1 plus 2 is just a 1. So this is going to give me 2 minus 1, which is a 1. 2 to the first, 2 to the 1 plus 2 minus 1. Well, 1 plus 2 is a 3, so 2 cubed is 8, and 8 minus 1 is a 7. And let's go ahead and plug in that last one just in case we need it. That's going to give us 2 to the -5 plus 2 minus a 1. Well, -5 plus 2 is a -3. So this is going to give me 2 to the -3rd, which is actually a 1/8, is -7/8. So that gives us 5 points here that we can go ahead and plot on our graph. The first being a -3 and a -1/2. So -3 and a -1/2 is about there. Then we have a -2, 0. We have a -1, 1. We have a 1, 7, and then we also had this -5 and a -7/8, which is about there. So we can see it is following the increasing shape, where it is rapidly increasing the further that you move to the right. All right, so pretty much the same graph, just this one is shifted left twice, once down. So let's talk about our decreasing function. Our decreasing function from left to right should be doing this shape right over here. So that means when I make my XY table for the decreasing function, I'm going to choose more numbers on the left-hand side. So let's see, I'm going to choose a -4 and a -2. I'm going to choose a 0 and then a 1. Just no particular reason. So I want to choose more on the left. So 2 on the negative side, always 0 and then something on the positive side. Otherwise, plug directly into your function. So this is going to be f of negative 4 is going to give us 1/2 to the negative 4 minus 1 power plus 2. So that's 1/2 to the negative 5th, which is actually 1/2 to the negative 5th is actually a 32, and 32 plus 2 is a 34, which is really, really big. So it looks like I'm not going to use that one. Let's try negative 2. If I find f of negative 2, that gives me 1/2 to the negative 2 minus 1 power, which is actually 1/2 to the negative 3. 1/2 to the negative 3 power is actually equal to an 8, and 8 plus 2 is a 10. So that does give me the point negative 2, 10 all the way up here. If I plug in a 0, so let's see, f of 0 is going to look like 1/2 to the 0 minus 1 plus 2. That's really just 1/2 to the negative 1. And 1/2 to the negative 1 is a 2. So this is 2 plus 2, which is a 4. That gives me the point 0, 4, which I can go ahead and plot right over there. Let's plug in a 1. All right, find f of 1, which is going to be 1/2 to the 1 minus 1 plus a 2. Now 1 minus 1 is just a 0, and anything to the 0 power is a 1. So this is really just 1 plus 2, which is a 3, giving us the point 1, 3. So I can see here my graph is decreasing the more I go left to right here. Let me just maybe find one more. I'm going to go ahead and plug in a 4 to see what it's doing over here. So finding f of 4, that is 1/2 to the 4 minus 1 plus a 2. Now 4 minus 1 is a 3, so that's going to give us 1/2 to the 3rd. Now 1/2 to the 3rd power is actually 1/8. And 1/8 plus 2, so that's just about 2 and an 1/8. So when I plugged in a 4, I got about a 2 and an 1/8, which is right about there. And what I know from my graph here is that for exponential functions, they have horizontal asymptotes at the x-intercept here. At y is equal, at the x-axis. So y is equal to 0 is what your horizontal asymptotes tend to be for these functions here. Right, notice they always hug that x-axis, forever getting close to it, but never intersecting it. So when we have a function here that has a plus 2, that means we're taking this graph, shifting it up 2. So it makes sense that this y equals 0 horizontal asymptote would move up 2, and we would have a horizontal asymptote at a positive 2. So for this one here, our graph, it does look like here it's following that, where it's going to hug this line here at a 2. And we can see that by our points here. They're getting closer and closer to 2, and they're going to forever just go along that line there, getting closer and closer with never crossing it. But that is a quick sketch of what that graph looks like.